Square roots. Find the square root of each of the following. Round to 2 decimal places if needed, and state whether the square root is a whole number or an irrational number. So recall that a square root is a whole number if the number we're taking the square root of is a perfect square. So some perfect squares are 1 squared is 1, 2 squared is 4, 3 squared is 9, etc. So if we take whole numbers and square them, they're perfect squares. If we're taking the square root of a non-perfect square, our result is an irrational number. And that means that the decimal expansion doesn't repeat a common pattern forever. So let's find these on the calculator. Okay, so for the first one, we have the square root of 64. Some calculators, you'd enter the square root sign and then you'd put 64. On this one, which is very, very basic, you type 64 and then you hit the square root symbol. And it says the square root of 64 is 8. So our result is 8. And that is a whole number. And that is because 8 squared is exactly equal to 64. Let's look at the next one, the square root of 26. Okay, so just something to think about before we put this in the calculator. 26 is not a perfect square. 5 squared is 25. 26 is a little bit bigger. The next perfect square is 36. So this is going to be a little bit bigger than 5, and it's definitely going to be irrational because it's not a perfect square. So let's get an approximation of it that's better than just a little bit bigger than 5. So we'll type 26 and the square root symbol. And we have 5.099, and notice we have a very long decimal expansion. Because it's irrational and there's no pattern here, so we are going to round to 2 decimal places. So if I go to the second decimal place, the third is a 9, so I'm going to round up. But the second is also a 9, so when I add 1 to that, I get 10. So it's going to be 5.10. And we're going to write approximately 5.10. Because the square root of 26 is an exact form, okay? Even this decimal expansion, this isn't exact. It's pretty accurate because it has a lot of decimal places, but the only way to write this exactly is in this form. This is an approximation. And since it's an approximation and it's not a perfect square, it is irrational. Okay. Next, we have the square root of 35. Notice 35 is a little bit less than 36, so this is going to be a little bit less than 6. But let's get a better approximation. And to 2 decimal places, the third is 6, so we're going to round up to 5.92. So this is approximately 5.92, and it is an irrational number since 35 is not a perfect square. Now we're going to look at some Pythagorean theorem problems which use square roots. So use the Pythagorean theorem to find the missing length of the given triangles. Round your answer to the 100th place when needed. Okay. So recall that the Pythagorean theorem applies to right triangles. So this is an example of a right triangle. A right triangle is a triangle, a 3-sided figure that has a right angle. We indicate it with this little square. Or if you're told it's a right triangle and there's no square, you should be able to determine which sides look like they're perpendicular. And you can think of this as how your wall should meet your floor, okay, as long as you don't have slanted walls or a slanted floor. Okay. The key distinction to make is between what we call the hypotenuse and the legs. The hypotenuse is the longest side and it's opposite the right angle. And we usually call it, well, we always call it C, almost always. The other two in the formulas are legs, and we label them A and B, but you could actually interchange the A and B. Which you call them is irrelevant. Okay, so if you need to solve for the hypotenuse, C, you're going to use this formula. And if you need to solve for either leg, you could think of it as these two separate formulas, but basically they're the square root of the square of the hypotenuse minus the square of the leg you know. So you're always given 2 values and you need to find the third. So looking at this first one, the first thing I do is I find the hypotenuse. And notice, in this case, we know the hypotenuse. That means we're solving for a leg. These are the two legs. This one is 8, this one is unknown. You can call it A, B, whatever you want to call it, or even question mark. I'm just going to call it question mark. So question mark equals the square root. Okay, you take the hypotenuse and square it, 14 squared, minus the leg you know squared. Okay. Now the square root works like parentheses, so we need to compute what's under the radical, that's what we call the square root sign, before we take the square root. So let's start by doing that and write our result. So 14 squared minus 8 squared is 132. So we have this equals the square root of 132. 132 is not a perfect square. It's okay if you don't know that, because we're going to check it by hitting the square root button. I already have 132 in there. And this is the decimal expansion. We're asked to round to the hundredths place. So notice in the hundredths place there's an 8. To the right there's a 9. So we're going to round up to 11.49. We're going to put approximately equals, because remember the square root of 132 is exact, and this is a decimal approximation of that. Let's look at the next one. So first I'm going to locate the hypotenuse. Here's my right angle. Opposite my hypotenuse is a question mark. So that means we're solving for the hypotenuse. The legs are 5 and 7. So we use this formula here, which basically means we're taking the square root of the sum of the legs squared. So we're going to take each of the leg values, square them, and add them together. Okay, so now let's put this in the calculator. Everything under the radical. So 5 squared plus 7 squared is 74. So this equals the square root of 74. And to get a decimal approximation, we'll hit the square root button. And to 2 decimal places, notice we're going to round down, it's 8.60. So this is approximately 8.60. Now let's look at C. Okay, notice C is kind of rotated from our original diagram. This one was too, but you need to use that right angle as your reference point. It doesn't matter how they spin or turn it. So here's my right angle. Opposite the right angle is the hypotenuse, which is 11. So we know the hypotenuse. We know one leg is 8, and we need to find the other leg. Okay, so we could use either of these formulas. Basically, we take the square root, square the hypotenuse length, so 11 squared, minus the leg we know squared, 8 squared. Now we'll find that part under the radical. 11 squared minus 8 squared is 57. So this is the square root of 57. Okay, that's going to be bigger than 7, the square root of 49, and less than 8, the square root of 64. But let's get a better approximation. Hit the square root button, and to 2 decimal places, notice the third's a 9, so I'm going to round up to 7.55. So this is approximately equal to 7.55.